History of development.
In 1882, Kamerlyon started a program to establish an equation of state after he was appointed to chair of experimental physics at University of Leiden. He wanted to make equation that works under low temperature. He worked with many methods to empirically derive functions of constant A and constant B of van der Waals by means of kinetic and or thermodynamics considerations, with less success. Then, he decided to combine systematically the whole set of experimental data available for the isotherms of several gases and liquids, independently as possible from theoretical considerations, and to express them in series. After some failures, he found that substituting data for a single substance with the experimental data of several substances within different limits and then combine all the information by means of law of corresponding states would enable him to achieve his goal. From this method, he determined the virial coefficient and built the equations of state. Finally, after few derivation for the general equations of state, the virial equation is formed because it fits experimental data at different temperature and different substances. For the equation he obtains is shown in the slide. For P is pressure of the gas, V is molar volume of the gas, T is the absolute temperature, and for C is the compressibility factor. While the B, C and D are the second, third and fourth virial coefficient respectively. They are function of temperature.
Definition. Virial equation of state is the most fundamental equation of state, and that has the most sound theoretical foundation. Besides that, an equation of state of gases that has additional terms beyond that for an ideal gas, which account for the interactions between the molecules.
Theory behind. The Virial equation is an important equation because there are exact relationship between the coefficients B, C and so on, as well as the interactions of molecules in pair, triplet, and so forth. Besides, Virial equation of state is a model that describes the properties of the real gas. The equation will give identical results to those of a perfect gas law as the pressure of the gas approaches to zero. However, this equation is not useful at higher densities, where the series may diverge, and is inapplicable to liquids. Besides, this equation fails when the virial coefficient becomes zero.
Compressibility factor is a useful thermodynamic property for modifying the ideal gas law to account the behavior of real gases. For ideal gas Z is equal to 1. While for real gas Z is either smaller than 1 or greater than 1. There are three behaviors of Z for real gas. For the first one is Z equal to 1 as the gas pressure approaches zero, all the gas tend towards ideal behavior. Second is Z smaller than 1 at the intermediate pressure because the intermolecular forces of attraction causing the actual volume to be smaller than the volume predicted by ideal gas law. For the last one is Z is bigger than 1 at high pressure because the intermolecular repulsive force is causing the actual volume to be bigger than the volume predicted by ideal gas law. For this part will be about the second virial coefficient of Pitzer correlation and virial equation of state. Z is equals to P bar V over RT.
This is the equation when we express in term of pressure. Z equals to P bar V over RT equals 1 plus B2 VdP plus BET squared plus B4 PTP cubed. When the pressure is small, P bar V over RT will be equal to 1 plus B2 VdP. The other term will drop out as they will give very small value. Equation of bar V equals to RT, P plus RT B2 PT. So, we can conclude that bar V equals to bar V ideal plus B2 VT, where bar V is the molar volume of real gas.
From the above equation,
B2 VT can be estimated from the following equations. B2 VT equals RTC over PC multiply with B naught plus omega B1, where B naught equals to 0.082 minus 0.422 over TR power 1.6 and B1 equals to 0.039 minus 0.172 over TR power 1.2.
The following will be the application of the virial equation. Let's read the question and understand it. Calculate the pressure exerted by 0.275 moles of nitrogen gas in 0.275 liter flask at 273 Kelvin using the first two terms of the series in virial equation. The value of B for nitrogen gas at 273 Kelvin is negative 10.5 cm³ per mole. Now, let's see how to solve this question. First, we need to convert all the terms to the correct units. Then, we need to find the molar volume of nitrogen gas by dividing volume of the gas with the number of moles. Now, we can find the value of pressure exerted by substituting the molar volumes and others values given in the Virial equation. The final answer of P is 12.4 bar. Same question can be solved using MATLAB. The answer acquired is the same with the one solved by calculation.
So that are all the contents of the video. Lastly will be the references we use for the production of this video. Thank you for watching, see ya and have a nice day.